Hello everyone. Welcome to the first version of our Unit 3 practice exam. So looking at our first question, we have circle each statement that is true. If x is less than 0, so we first have to interpret what that means. So if x is less than 0, that tells us that x is going to be a negative number. So if x is a negative number, then this is saying, then negative square root of x is an imaginary number. So here we can just ignore this negative right here because we just have to remember what does it even mean to be an imaginary number? And that's just simply the square root of a negative value. And if x by definition is negative, then taking the square root of a negative number does become imaginary. So therefore, answer choice number 1 is correct. Let's look at number 2. Number 2, given a quadratic equation, ax squared plus bx plus c equals 0, if b squared minus 4ac is greater than or equal to 0, then there will only be real number solutions. So let's see what that says. So if we remember, this is our quadratic equation, and this portion right here, b squared minus 4ac, is actually the discriminant, or in other words, the radicand of the quadratic formula, as such. So if it's greater than or equal to 0, what that tells us is that if it's greater than 0, the discriminant is positive, and if it's equal to 0, that's just equal to 0. So we just have to think to ourselves, well, what happens when the discriminant, or this radicand, is positive or 0? So if it's real number solutions, that means, again, it could be rational or irrational, and so the only time that it cannot be a real number solution is if it's imaginary, and the discriminant would be forced to be negative to be imaginary. So therefore, answer choice number 2 is also correct. So again, if it has a discriminant that's positive or even equal to 0, the solutions are always going to be real. So even if it's irrational, it's still a real number. Looking at number 3, in a quadratic linear system, it is possible to have 3 solutions. So we have to remember a system is just saying that these two equations or graphs simultaneously exist. And in order to be a solution, we know that that's a point of intersection, graphically speaking. So quadratic linear means that we have one parabola and one line. It doesn't have to be in these directions, but in order to have 3 solutions, there has to be 3 points of intersection. And so here this is false because it's impossible to have 3 points of intersection between a parabola and a line. At most, it's possible to have 2, to have 1, or to have none as such. Number 4 says, given a quadratic equation with real coefficients, it is possible to have only one imaginary solution. So this is something that we discussed in class a while ago. So if you ever forget, we just have to think to ourselves, well, what does it even mean to get an imaginary solution? Well, we would have to take the square root of a negative value. And so again, whenever we take the square root of a quadratic equation of a negative value as such, when we take the square root, we have to remember that there's always 2 solutions because of that plus minus, therefore telling us that it's impossible. And aside from that, it's also impossible because of the complex conjugate root theorem that we talked about on worksheet number 30. Okay, let's look at number 2. So number 2, here they give us this equation. They tell us 2x squared minus 4x is equal to t. And here they tell us that in the equation above, t represents a constant. And again, a constant is just some random number. And then they tell us if the equation has no real solutions, which of the following could be a value of t? So we again have to interpret what the question is asking for. Sorry, give me a second. Okay, so what does it even mean to be no real solution? So if it's not real, then therefore it's imaginary. So if we have imaginary solutions, so in this case, every single time a problem talks about the types of solutions, the nature of the roots, whatever, that's a key thing to tell that indicates to us that we're going to use the discriminant. So if we have imaginary solutions, again, the quadratic formula is up here for us to use. So we don't have to memorize each condition of the discriminant and what type of solutions it gives us, but rather just rationalize what that means. So in order to get imaginary solutions, we can see that the discriminant must be negative because, again, the square root of a negative value is imaginary. So that tells us that b squared or the discriminant is negative, or in other words, b squared minus 4ac is less than 0, because all negative numbers are less than 0. So next thing is that we know that in order to find the discriminant, we're using the discriminant in the quadratic formula. So what we'll have to do first is to make sure that our equation is equal to 0, because what we're doing is technically looking for solutions. So let's first make sure that we rewrite the equation such that it's equal to 0, so that way we can determine the types of solutions. So we're going to subtract t on both sides, thus giving us 2x squared minus 4x minus t is equal to 0. And then from here, can we use the discriminant? So once again, we need to know the values of a, b, and c. So in this case, a is 2, b is negative 4, while c is negative t. So substituting those values into our discriminant allows us to extract information about what t could be, since that is what the question is asking for. So then this gives us 16 plus 8t, because we have negative 4 times negative t is plus, less than 0. And then now solving for t, we can subtract 16 on both sides, thus giving us 8t is less than negative 16. And then dividing both sides by 8 gives us t is less than negative 2. So looking at the answer choices, we just have to choose which one of these satisfies this inequality. And the only one would be answer choice number 1, that negative 3 is indeed less than negative 2. Looking at number 3, we have expressed the solution to the equation below in simplest radical form and simplest a plus bi form. So let's look at this equation here. So all we have to do is to solve for x, because that's what it means to express this, find the solution. So let's do that first by subtracting 50 on both sides, thus giving us 9x squared is equal to negative 50. And then isolating x even more, let's divide both sides by 9, thus giving us x squared is equal to negative 50 over 9. Now from here, we have to take the square root of both sides of the equation in order to isolate x. And so once again, to simplify, we can take the square root of both the numerator and denominator respectively as such, taking the square root of negative 50 over square root of 9 as such. And then from there, we can break it down even more, giving us square root of negative 25 times square root of 2 all over square root of 9. And so from here, square root of negative 25, because we have this negative, we know that translates into I, and then square root of 25 is 5, so that gives us 5i radical 2, and then in the denominator, radical 9 is just 3. So therefore, that gives us our answer, x equals 5 radical 2 over 3, and the I at the very end, because we have to write it in a plus bi form. And then don't forget the plus minus, because we're changing a quadratic equation into a linear one. So we have to account for the fact that there are two solutions. Okay, let's look at number 4. So number 4 looks quite ugly because of these very large numbers. But again, they ask us for the solution. And so notice that in all of these questions, or all of these all of these answer choices, that they all have i's in them, and they all have radical 158. So this is actually going to help us a lot in determining which method to use. So whenever we have an equation, instead of just starting off, we want to think about, okay, how can we simplify the equation so that way we have smaller and easier numbers to work with. And so here we can see that in the first equation, or original equation, we can divide everything by 3. Whoops. Okay, dividing by 3 thus gives us 6x squared minus 8x plus 29 is equal to 0. And so from here we got many options, but we have to remember the two things that always work is always going to be completing the square and quadratic formula. So if we do go about completing the square, we have to make sure a is equal to 1, which is going to be very annoying because we would have to divide by 6 and then leaving us to work with fractions. So instead, this is one of the rare moments where I will say using the quadratic formula is more beneficial. So let's identify a, b, and c here. So we know that a is going to be 6, b is negative 8, while c is positive 29. And so substituting that into the quadratic formula gives us as such. Now, what we want to do from here is number 1. If we're substituting in a negative value, we have to be sure to put parentheses around everything. And then now when we simplify, we also have to remember to put parentheses as such. So now this is going to give us positive 8 plus minus 64 minus 696 all over 12. And now, so from here, simplifying the discriminant, 64 minus 696 is going to give us negative 632. And so right here, this is going to be annoying because, well, we have this very large number, negative 632. And you might be thinking to yourself, well, how do I know what to use to simplify this radical? And so what we can do is, well, that's where the answer choices come in. Notice here that every single answer has 158 in it. So what we can do is maybe try taking this value and dividing by 158 and seeing what we get as a result. And so when we do that, we can simplify this into 8 plus minus 2i radical 158 all over 12. Because this one right here, negative 632, is the same thing as negative 4 times 158. And if we take the square root of each, negative 4 gives us 2i as such. And then so at this point you might think, well, this still doesn't look anything like any of the answer choices. And here this is where we have to employ this concept of breaking apart this fraction into two parts. So we can rewrite this as x equals 8 over 12 plus minus 2i radical 158 all over 12. And then from here we can simplify even more. 8 over 12 then becomes 2/3, while the 2i over 12 simplifies to I over 6 as such. And then therefore that gives us answer choice number 4 right here. Okay, so again, it doesn't look that similar, but you can break it down as such. The denominator of 6 translates to 1/6, and then we have the I radical 158 as such. Okay, let's move on to number 5. So number 5 says express 3 minus 2i squared minus 4 plus 7i squared in simplest a plus bi form. So in this situation, we got a multitude of methods, but the first thing that we can notice is, well, if we look right here, this is actually a difference of two perfect squares. So if we want to, we can rewrite it as such. Let's say let's let a equal 3 minus 2i, while b is 4 plus 7i. So if we rewrite it or translate it, we can rewrite it as a squared minus b squared, a difference of two squares. And we know that we can factor that into a plus b times a minus b. And so by substitution, if we were to apply what a and b truly is, that will give us 3 minus 2i plus 4 plus 7i times 3 minus 2i. Oh, geez. Okay. 3 minus 2i minus 4 plus 7i. And so from here, because in the first set of parentheses, this is just straight up all addition, we can just combine like terms, thus giving us 7 plus 5i. Now in the second one, because they're subtraction, we have to remember to distribute the negative to each term in the second one, because we're subtracting the entirety of b and not just the first term. So we have to have 3 minus 2i minus 4 minus 7i. And then finally combining like terms in this one right here will thus give us negative 1 minus 9i. And then from here we have to employ double distribution, so multiplying everything out as such, thus gives us negative 7 minus 63i minus 5i, and then minus 45i squared. And so from here we can combine like terms. So combining like terms there gives us negative 7 minus 68i minus 45 times negative 1, because we have to remember that I squared is equal to negative 1, just by definition. This is just something that we have to remember. And so simplifying even more gives us a positive 45, and upon combining like terms between the two constants gives us our final answer, 38 minus 68i. Okay, so that's method number 1 if we choose to interpret it by a difference of 2 squares. So now let's say on the test, let's say you have made your brain fart and you choose to multiply it out as it is. And that's perfectly fine as well. But we just have to remember one key thing. So let's first multiply this part out. So 3 minus 2i. Again, we cannot distribute exponents. We cannot distribute exponents. That's illegal. Don't do it. Don't do it. Because we should result in a trinomial. So that should give us 9 minus 12i plus 4i squared. And so now when we choose to square the second expression, we have to remember to keep it in a set of parentheses because we're using subtraction. We're subtracting the entirety of whatever that product will give us. So that's going to give us minus, in parentheses, 16 minus 50 plus 56i plus 49i squared as such. And then from here, in order to accurately subtract this entire expression, we have to distribute the negative to each term, therefore giving us negative 16 minus 56i minus 49i squared. So again, there's a multitude of ways to do this. You don't have to do it exactly how I'm going about it, as long as it's mathematically sound. So from here, after we combine like terms, combine all the constants, and then the i's, and the I squareds gives us negative 7 minus 68i minus 45i squared. And once again, from here, because we know I squared is equal to negative 1, then it becomes very similar to what we saw in method number 1, and therefore giving us the same exact answer of 38 minus 68i. Okay, now let's look at the next one. It says, write a quadratic equation with a leading coefficient greater than 1 and a root of negative 5 minus 8i. So this is as such. So we remember all quadratic equations follow the format of ax squared plus bx plus c is equal to y as such. And so when they say leading coefficient greater than 1, we have to remember leading coefficient is just the coefficient attached to the variable with the highest exponent, in this case a. So they just want us to write an equation such that a is greater than 1, maybe like a 2, 3, 4, or whatever. So here they only give us one specific root, which is negative 5 minus 8i. And so from here we have to remember that it is impossible to only have one singular imaginary root or complex root. So we know that by the complex conjugate root theorem, there's going to be two roots, in this case, negative 5 plus minus 8i. Okay, so from here we can do two methods. So let's go through the first method. And the first method, I informally called it just like reversing the solving of x. So what we can do is add 5 on both sides, thus giving us x plus 5 is equal to plus minus 8i. So from here we have to remember our goal is to write a quadratic equation. So we want to think to ourselves, how can we make this into a quadratic equation? And we can do that by squaring both sides of the equation as such. So raising it to the power of 2. And so on the left side, that's going to give us x plus 5 squared, while on the right side will give us negative 64. Because whether it be positive 8i times itself or negative 8i times itself will always result in negative 64. And then so from here we can multiply the x plus 5 out, giving us x squared plus 10x plus 25 is equal to negative 64. And then isolating or making the equation equal to 0 will give us plus 64 on both sides, thus giving us x squared plus 10x plus 89 is equal to 0. And then so from here, let's say you only chose to do this method. If they ask for a leading coefficient greater than 1, we just have to remember in order to get other equations, we can just generate them by multiplying by a constant to create equivalent equations. So for example, possible answers can include, let's say we multiply this entire equation by 2. If we multiply by 2, that will give us, 2x squared plus 20x plus 178 is equal to 0. Or we can multiply by 3, or we can multiply by 4. It really doesn't matter. All they care about is having a leading coefficient that is greater than 1. Now let's say you choose to do another method. or in other words, using the sum of the roots and the product of roots. So if we choose to use this method, we just have to remember what the expressions are for each of them. So for sum of the roots, we would have to add the two roots together, and that would be whatever negative b over a is, while the product of roots is going to be whatever c over a is. So in this case, the sum of the roots, adding these two roots together, gives us negative 10, while the product of the roots gives us 89. So I already have it down here, and you'll see that I already set a is equal to 1. Do we always have to do that? No. But is it the easiest? Yes, because it won't change the value of whatever we calculated as such. So therefore, this is going to give us, if a is 1, then we can say that b is, in this case, positive 10, because we have to remember this has negative b. So if it's negative b is equal to negative 10, then b itself is just 10. And then looking at our product of roots, this tells us that c is equal to 89. So therefore, that is our final answer. Substituting in all a, b, and c gives us the same answer that we got from before. And once again, to generate more possible answers, we just have to multiply by some sort of constant to create equivalent equations. Okay, let's look at number 7. So number 7 says, algebraically determine the solution set of the following system of equations. So we don't have to start like this, because if we look carefully, the first equation has y already isolated. So if you wanted to, you could have totally taken this entire expression and substituted it into the first equation. Doesn't really matter. But I'm also going to do another method as well, which is to isolate y in the first equation. So isolating y in the first equation, we can add 3x on both sides, thus giving us y equals 3x plus 6. And then so from here, we're going to substitute this expression into the equation that we didn't touch yet as such. So this is going to give us 3x plus 6 equals x plus 4 squared minus 10. And then so from here, we know for sure that we want to solve for x, so we have to equal this entire equation to 0. So let's do that first by multiplying out this x plus 4 squared. And that's going to give us x squared plus 8x plus 16 minus 10 as such. And then now subtracting 3x and, oh, whoops, I didn't do that. I combined like terms first, giving us positive 6 here. And then we can subtract 3x and subtract 6 on both sides, thus giving us x squared is equal to 0 equals x squared plus 5x. And then so from here we can just factor out the common factor of x, giving us 0 equals x times x plus 5. And using the zero product property tells us that each factor is set equal can be 0, giving us x is 0 and x is negative 5. And so we have to remember that in order to solve a system, we have to express our solutions as coordinates, because that's what it means. We have a line and a parabola, and so we're looking for all the points of intersection. So from here, this is going to give us the opportunity to find the y values, and we're going to do that by substituting into that equation that we got from before. So we have x is 0 and x is negative 5, and substituting that into the equation gives us as such. Okay, and so substituting in our values for x, let's find our values of y, and therefore that gives us 6 and negative 9 respectively. And once again, in order to express our solutions, we have to write them as coordinates, so therefore that gives us, in this first one, 0, 6, and in the second one, negative 5, negative 9. Okay, let's look at the next one, number 8. Rewrite the expression as a product of 4 linear factors. So notice here that this itself is not an equation, so whether the instructions were to say this or just to say to factor completely, we would not solve for any solutions because it is not an equation, it's an expression. So from here, this is a little bit weird, but what we can try doing is try to translate this into an easier problem. So we notice that there's a repetition of this 4x squared plus 5x as such. And so let's use a random variable, let's say y. So let's say let y equals 4x squared plus 5x as such. And so what this is going to allow us to see is it exposes some sort of structure that's easier to factor. And so if we translate it in terms of y, that's going to give us y squared minus 5y minus 6 as such. And then so from here we can see, well, this looks like a pretty simple trinomial that we know how to factor. So we can factor this into y minus 6 times y plus 1. And then from here, now we can employ our substitution. So taking the value of y and substituting it back into these two expressions gives us 4x squared plus 5x minus 6 times 4x squared plus 5x plus 1. So that's what we have so far. But the question itself is asking for 4 linear factors. So as of now, we only have 2. So that tells us that we can factor each of these trinomials even further. And so from here, we can either employ mental math or we can use the AC method, which is always going to work. So I'm going to do one of them with y'all, and then the other one, if you have questions, you can ask me in real life. So here, this is our first expression, 4x squared plus 5x minus 6. And if we're choosing to go about the AC method goes as such. We're finding factors of a times c, which in this case is negative 24. So we're looking for factors of negative 24 that add up to positive 5. And so in that case, that's going to give us positive 8 as well as a negative 3. So we use those factors of negative 24 to split up the 5x as such. And then so from here we factor by grouping, so we can group the first two terms together and then grouping the last two terms together, and factor out the GCF in the first one gives us 4x times x plus 2, and in the second one we have negative 3 times x plus 2, giving us our final answer of x plus 2 times 4x minus 3 as such. So that gives us our factors for the first one. So that gives us 4x minus 3 times x plus 2. And in the second one, if we use AC method or mental math, that's going to give us 4x plus 1 times x plus 1. And that concludes our answer for number 8. Now let's look at number 9. Number 9 says the equation below is solved incorrectly. Write the correct steps and find the values of x. So let's look at what we have here. So they have x minus 2 squared plus 16 is equal to 25. And if we look carefully, it seems that from the first to the second line, they decided to take the square root of both sides of the equation. So we have to keep in mind that that is absolutely wrong, because here there's an addition sign. Even though 16 is a perfect square, the entire expression itself is not a perfect square, hence why we cannot take the square root. So what we have to do is to slowly isolate x as such. So we're going to take 16 and we're going to subtract it on both sides, giving us x minus 2 squared is equal to positive 9. And then upon here, taking the square root of both sides, thus gives us x minus 2 equals plus minus 3, because we're changing a quadratic equation into a linear one. And then solving for x, we just add 2 on both sides, giving us x equals 2 plus minus 3. So we just have to remember that this translates into two different things, 2 plus 3 and 2 minus 3. So doing both of those operations gives us our final answers of negative 1 and positive 5. And that's it. Okay, let's look at number 10. So number 10 says algebraically determine all solutions to the equation. So we have a multitude of things that we can start off with. What I always recommend is to factor out the GCF. And in this case, there does exist a greatest common factor of x. But let's say on the test that you don't remember to do that. And that's perfectly fine. So I'll show you how to do it when you don't remember the greatest common factor. So whenever we see 4 terms that cannot be combined, that typically indicates to us we got a factor by grouping. So let's group the first 2 terms together and then group the last 2 terms together as such. And then so from here, let's factor out the GCF in the first one. In this case, that's going to be 4x to the third power, leaving us with 4x to the third power times 2x minus 3. And then in the second set of parentheses, that's going to be, we can factor out a 25x times 2x minus 3 as well. And then because they have the same exact factors, we can factor that out, giving us 4x to the third power plus 25x times 2x minus 3 is equal to 0. And then so from here, we can employ the zero product property. But if we notice carefully in the first one, in the first factor, we can still factor this even more. In fact, we can factor out an x. So factoring out an x gives us x times 4x squared plus 25 times 2x minus 3. And then from here, it would be very nice to employ the zero product property. Because again, we see multiplication of 3 factors. And so if that equals to 0, that tells us that each factor can equal to 0. Hence why we have what we have here. So the first solution is already given to us, x is equal to 0. Now the second solution we actually have to solve for. So we have to subtract 25 on both sides, thus giving us 4x squared is equal to negative 25. Dividing both sides by 4 to isolate x gives us x squared equals negative 25 over 4. And once we take the square root of both sides, that gives us x equals plus minus 5i all over 2. Or we can write 5 over 2i is the same thing. And then lastly, from here, we can add 3 on both sides. Dividing by 2 gives us x equals 3 over 2. So this gives us our 4 solutions. X is 0, negative 5i over 2, positive 5i over 2, and positive 3 over 2. And so that concludes our answer for number 10. Okay, let's look at number 11. Okay, so looking at number 11, here they say algebraically determine all roots to the equation and express in simplest a plus bi form. So here we have to notice that, well, this is a quadratic equation. So let's first make sure that in order to determine the roots, we set the equation equal to 0 by subtracting 60x on both sides, thus giving us 5x squared minus 60x plus 405 is equal to 0. If you want to write the equal to 0 on the other side, that's okay too. I just left it like this so it's prettier. So from here we can do a multitude of things, but the first thing that we want to try seeing is, well, is there a way that I can simplify this equation? And in this case, yes, because we see that all 3 of these terms are divisible by 5. So we can divide by 5, thus giving us x squared minus 12x plus 81 is equal to 0. And so from here, we're left with either factoring, completing the square, or quadratic formula. And in this case, it's not going to be possible for us to find factors of 81 that adds up to negative 12. So in this case, I would say it's, I personally would go about not quadratic formula, but completing the square. Because a is already 1, and the value of b is an even value. So that's going to be nice to complete the square with. So let's do that by subtracting 81 on both sides, thus giving us x squared minus 12x, and then we leave a blank, equals negative 81. And so from here now we have to complete the square, and if we remember completing the square, we need b over 2 squared to add on both sides. In this case, b is negative 12. So we have negative 12 over 2 squared, giving us negative 6 squared, or in other words, 36. So we're going to add 36 to both sides of the equation to maintain the equivalence, therefore giving us on the left side, we can factor that into x minus 6 squared, and then on the right side we have negative 45. So going further, to solve for x, we take the square root of both sides of the equation. And so from here, we want to find the largest perfect square that goes into 45. In this case, that's going to be 9. So there's going to give us x minus 6 equals plus minus 3i radical 5. And solving for x gives us plus 6 on both sides, or in other words, x equals 6 plus minus 3i radical 5. Now, because the problem says to write it in a plus bi form, let's just rewrite it such that the I is at the very end, thus giving us 6 plus minus 3 radical 5i. So keep in mind, when we write this, we have to make sure that we cannot put I underneath the radical. So it has to be on the very outside, as if like it's a variable. Okay, and now moving on to our last question. Number 12, the biggest one. Okay. Solve the following system for all solutions. So over here, what we can do is take this first equation and let's think about what variable we can isolate. And we see that x already has a coefficient of 1, so let's isolate x by subtracting 3y on both sides, giving us x equals negative 3y plus 1. And so from here, we're going to take our original equation, the first one that we didn't touch yet, and then we're going to substitute x equals negative 3 minus 1 wherever we see x. So from here, again, the reason why we want to do this is because when we see this equation, we only have one variable. We want to have an equation of one variable so that way we can solve for one at a time. And so from here, let's combine like terms, and combining the positive 1 and negative 4 gives us negative 3. So we have negative 3y minus 3 squared equals plus y plus 2 squared equals 85. And again, we cannot distribute exponents. We cannot distribute exponents. We have to multiply it out. So this is going to give us positive 9y squared plus 18y plus 9 for the first binomial squared. And in the second one, y plus 2 squared will give us y squared plus 4y plus 4 and then equals 85. So from here, let's combine like terms in this left side, giving us 10y squared plus 22y plus 13 equals 85. And we know that in order to solve for any variable, we have to make sure it's equal to 0. So let's equate this to 0 by subtracting 85 on both sides, thus giving us 10y squared plus 22y minus 72 equals 0. And again, if we can simplify the equation, let's try to do that. And so we're going to divide both sides by 2, thus giving us 5y squared plus 11y minus 36 is equal to 0. And so from here, we can factor this by using AC method. So you can either solve by factoring as such, or you can use the quadratic formula at this point if you don't want to deal with that. But I would recommend factoring because these types of problems will not give you like imaginary solutions or very ugly irrational solutions, especially on the regents. They're always going to be rational. So in other words, a whole number or a decimal. And so therefore factoring gives us 5y minus 9 times y plus 4 equals 0. And then by zero product property, we can set each of them equal to 0. And then solving for y gives us y equals 9 over 5 or y equals negative 4. And then finally, we have to solve the equation for, solve this entire system for the solution, so we need coordinates. So we're going to take this value right here and, okay, before I ran out of storage, as I was saying, we have these y values here and we have to find the coordinates, so we're going to use this first equation that, okay. Before I ran out of storage, as I was saying, we have these y values here and we have to find the coordinates, so we're going to use this first equation that we manipulated in the beginning to solve for x. So we're going to solve for x right now using the y values that we found. So y is equal to 9 over 5 and y is equal to negative 4. Once we substitute both values into the equation, then we get negative 22 over 5 and 13 respectively. So in this sort of situation, we have to be very careful because we always have to remember that our solutions are in the form of x comma y. So x is negative 22 over 5 while y is 9 over 5. And then for the second one, x is 13 while y is negative 4. And so that concludes our video for this practice test, and I'll see you in the next one. Bye!